Let's look at a problem that involves solving a differential equation using a power series given initial conditions. Recall that a power series is in the form c sub 0 plus c sub 1 x plus c sub 2 x squared plus c sub 3 x cubed plus c sub 4 x to the fourth, and so on. Finding the first derivative of this series, we get c sub 1 plus 2c sub 2x plus 3c sub 3x squared plus 4c sub 4x cubed, and so on. Differentiating again, we find that the second derivative is 2 times 1c sub 2 plus 3 times 2c sub 3x plus 4 times 3c sub 4x squared, and so on. So, if y satisfies the equation y double prime equals x cubed y, then we can set the expression for y double prime equal to x cubed times the expression for y. Using the fact that coefficients of the same degree must be equal, let's determine an expression for each coefficient. So we have 2 times 1 times c sub 2 is equal to 0. 3 times 2 times c sub 3 is equal to 0. And 4 times 3 times c sub 4 is equal to 0. If we continue, we find that 5 times 4 times c sub 5 is equal to c sub 0. 6 times 5 times c sub 6 is equal to c sub 1, and so on. In general, we find that for n greater than or equal to 5, we have n times n minus 1 times c sub n is equal to c sub n minus 5. In fact, we can write each term in terms of c sub 0 or c sub 1. Solving for each coefficient, we know that c sub 2 through c sub 4 are equal to 0. Then we have c sub 5 is equal to c sub 0 over 5 times 4. Next, we have c sub 6 is equal to c sub 1 over 6 times 5. Continuing, we find that c sub 7 is equal to c sub 2 over 7 times 6, which is equal to 0, since c sub 2 is equal to 0. Similarly, we get c sub 8 equals c sub 3 over 8 times 7, which is equal to 0. And then c sub 9 equals c sub 4 over 9 times 8, which is equal to 0. Now, we have c sub 10 equals c sub 5 over 10 times 9. Since c sub 5 is equal to c sub 0 over 5 times 4, we can substitute that in. So we get that this is equal to c sub 0 over 5 times 4 times 10 times 9. For c sub 11, we will get c sub 6 over 11 times 10, which is equal to c sub 1 over 6 times 5 times 11 times 10. If we continue on, we would get a c sub 2 in the numerator, so our next term would be 0, and so on. So each term will either be 0 or contain c sub 0 or c sub 1. Substituting each expression we found for the coefficients into the power series, we can write y using c sub 0 and c sub 1. Then using the initial conditions, we can see that y of 0 equals 2 implies that c sub 0 equals 2, and y prime of 0 equals 5 implies that c sub 1 equals 5. Substituting these into y and factoring, we find that y is equal to 2 times 1 plus x to the 5th over 5 times 4 plus x to the 10th over 5 times 4 times 10 times 9, and so on, plus 5 times x plus x to the 6th over 6 times 5 plus x to the 11th over 6 times 5 times 10 times 11, and so on.